Hello everyone, I am Professor Anish Vora and I welcome you all in this video lecture. In this video lecture, we will study about M notations of Boolean function. For Boolean function, we use M notation, and if we classified M notation, then it can be classified in two categories. One is known as a minterm. In case of SOP form of Boolean function, that is sum of product, we use minterm, and in case of POS, that is product of sum, we use the term that is known as a maxterm. Now let us start with the minterm. Each individual product term in standard SOP is known as the minterm. In standard SOP only, we have each individual product term, and that is known as a minterm. For n number of variables, total number of minterms are 2 raised to power n. So for example, if we have 3 variables a, b and c, then total number of possible minterms, that is 2 raised to power 3, that is 2 multiplied by 2 multiplied by 2, and that is equal to 8. In product term, we have literals. It can be complemented if variable is 0. It can be uncomplemented if variable is 1. Suppose we take one canonical form of the SOP, that is sum of product, for function f of ABC is equal to a bar, b bar, c plus a, b, c bar plus a bar, b, c. These all are product terms, and that is known as the minterms. Because the function is a standard SOP, so all the product terms, each product terms is known as the minterms, and in each product term we have different literals: a bar, b bar, c, a, b, c bar, a bar, b, c. So literals can be complemented or it can be uncomplemented, and that depends on the variable. So now let us understand minterms in detail. We have minterms. It can be indicated by small m and suffix I. Small m, that is for minterm, and suffix I is equal to decimal equivalent to binary number. Now suppose we take one example. We have 3 variables a, b and c. Based on the value of variable a, b, c, whether it is 0 or 1. If 0, literal will be complemented. If variable is 1, literal will be uncomplemented. And we have decimal equivalent number. This 0, it is a decimal equivalent number. So first condition, that is 0, 0, 0. And decimal equivalent is 0. That is why it is minterm is known as M0. Suffix 0 is for decimal equivalent number. So we have a product term a, b, c, but all input variables are 0, 0, 0. So we have a bar, b bar and c bar. This is our minterms for decimal number, equivalent decimal number 0. Same way, we have equivalent decimal number 1 for 0, 0, 1 condition. M1 can be a bar, b bar, c, because a is our most significant bit and c is the least significant bit, and we have condition 0, 0, 1. So 0, a bar, 0, b bar, 1, c. And equivalent decimal number, that is 1. So it is minterm is indicated with 1 suffix. So it is known as M1. Same way for 0, 1, 0, that is M2, A bar, B, C bar, 0 1 1, that is decimal equivalent 3. So M3 A bar B C. 1 0 0 M4 A B bar C bar. 1 0 1 5 M5 is equal to A B bar C. 1 1 0 M6 A B C bar. And the last we have 1 1 1 condition and decimal equivalent is 7. So minterm is known as M7 and it can be indicated as ABC. We can see that minterm is a product term. We have 3 input variables. So total possible minterms, that is 8, and according to equivalent decimal number we give suffix number M0, M1, M2, M3, M4, M5, M6 and M7. Now let us take one Boolean function, that is in canonical or standard sum of product term. We have 3 product terms A, B bar, C. So for complemented we take 0, for uncomplemented we take 1. So A, B bar, C, that is 1 0 1, A, B, C, that is 1 1 1, and A bar, B, C, that is 0 1 1. If we write equivalent decimal number, then 1 0 1, we know that it is 5, 1 1 1, that is 7, and 0 1 1, that is 3. So for each product term, now we can write minterm, that is M5 plus M7 plus M3. If we rearrange, then we can write M3 plus M5 plus M7, and it can be written as sigma M and 357 suffix. We have 3 minterms M3, M5 and M7. So we can write 357 where sigma indicates sum of product. Symbol sigma we use in this equation to indicate sum of product term. So this way we can write our Boolean function in terms of minterms. Now let us take one truth table. We have different condition, 3 input variables. So we have total 8 input possible condition. Now to prepare SOP form, we have to follow certain step. So step number 1, write each input combination in product term for which output is 1. So for output where we have output 1, that input combination we can write in product term and then add all product terms to make it SOP form, that is sum of product. So first we identify the products and then we add, so we get SOP form. So we have output at 3 different condition, one output, high output at 3 different condition, that is for 0 0 1, 1 0 1 and 1 1 1. So if we see the decimal equivalent number for 1, for 5 and for 7, we have high output. So now if we write SOP form, then f of ABC, it can be written as sigma M, sigma that is SOP, M that is minterm, 1, 5 and 7. Meaning is for decimal equivalent 1, 5 and 7, output is high or 1. We can write as a M1 plus M5 plus M7, and for each equivalent minterm, if we identify the product terms, then M1 we can see it is 0 0 1. So we can write A bar, B bar and C. For M5 we have 1 0 1 condition, so A, B bar, C, and for 7 we have 1 1 1 condition and we can write as a ABC. So this is our SOP form with minterms and we have to write only those minterms for which we are getting output 1. So now let us study about the maxterm. Each individual sum term in standard POS form is known as a maxterm. Now here we have canonical or standard POS, that is product of some form of Boolean function, and each individual sum term is known as the maxterm. N variables, we have total number of possible maxterms, that is 2 raised to power n. Again, if we have 2 input variables, then total number of maxterms can be 2 raised to power 2, that is 4. For 3 input variables, we have total number of maxterm, that is 2 raised to power 3, so it is 8. And in each sum term, we have literals, but now here it is different compared to minterms. In case of maxterm, literals will be complemented if variable is 1, and it will be uncomplemented if variable is 0. This is major difference compared to minterms. In minterms, it is differently reverse condition. So here we have to always remember that literals in maxterm, it will be complemented in case of variable is 1, and it will be uncomplemented if variable is 0. Now suppose we take one standard canonical product of some form. We have f of abc, and that is equal to a bar plus b bar plus c dot a plus b bar plus c dot a plus b plus c bar. So these all are sum terms, and that is known as maxterms. Now maxterm can be indicated as a capital M and suffix I. Capital M we use for maxterm, small m we use for minterm, and meaning of I is similar in case of maxterm as well as minterm. So suffix I, that is equal to decimal equivalent number compared to binary number. So now again we have 3 input variables, and we have to consider maxterm. Now we should always remember that during calculating maxterm, if input variable is 1, then we have to take a literal complemented, and if input variable is 0, then we will have to take uncomplemented. Now we have first condition, that is 0 0 0, decimal equivalent, that is 0. So we have to write M0, suffix 0 for decimal equivalent number. We have all zeros input variables, so all the literals will be in uncomplemented form, and we have to prepare sum term. So a plus b plus c. Now 0 0 1, that is M1. For 0 0, we have uncomplemented literal, that is a plus b, and for 1 we take a c bar. So it is a plus b plus c bar. A is the most significant bit and c is the least significant bit. So when we consider 0 0 1, meaning is a is 0, b is 0, and c is 1. So we take ABC. 0 1 0, M2, a plus b bar plus c. 0 1 1, M3, a plus b bar plus c bar. And in similar way, we have last condition, that is 1 1 1. Decimal equivalent, that is 7. So it will be considered as a M7, maxterm number M7. But now we have all 3 variables at a high level or 1 level. So in some term, all the literals will be complemented. So a bar plus b bar plus c bar. So this way, for 3 input variable, we have maximum possible maxterms, that is 8, M0, M1, M2, M3, M4, M5, M6 and M7. But the condition is depends on input variables. We have to take a literals either complemented or uncomplemented. 1, if input variable is 1, we have to take complemented literals, or 0, we have uncomplemented. Now let us take one function, Boolean function, that is f of ABC, and that is equal to a plus b bar plus c, a plus b plus c, and a bar plus b plus c. Now if we write binary numbers, then for uncomplemented we have to write 0, for complemented we have to write 1. So first condition, a plus b bar plus c. So we can write 0, 1, 0, and decimal equivalent is 2. For a plus b plus c, all literals are uncomplemented, so we have to write 0, 0, 0, and decimal equivalent is 0. Again, we have to write a bar plus b plus c. So it can be written as 1, 0, 0, and decimal equivalent is 4. So if we write now max terms for the given Boolean function, then we can write as a m2 plus m0 plus m4, capital M for max term. Again, if we rearrange, then we can write as a m0 plus m2 plus m4, and it can be written as a pi into bracket 0 to 4. 0 to 4 indicates our decimal equivalent number, and pi, that indicates that Boolean function is product of sum. So this way we can have a max terms. Now suppose we take a one truth table, similar truth table which we had taken for Minterm. So we have different 8 condition, we have 3 input variables. Now to prepare product of sum term, POS term, we have certain steps. So step 1, write each input combination in sum term for which output is 0. Now it is very different compared to SOP form. So for each output 0, we'll have to write input variables in sum term, and then we have to multiply all sum terms to get product of sum form. So now we identify each output where we are getting 0 output. So we have for decimal number 0, 2, 3, 4 and 6, we are getting 0 output. So we have to write the sum terms for output where we are getting 0. So if we write a POS form, then f of ABC can be written as a pi into bracket 0, 2, 3, 4, 6. So pi indicates POS form, and 0, 2, 3, 4 and 6, these are decimal equivalent number for which input we are getting output 0. So this can be written as capital M, that is for the max term, M0 plus M2 plus M3 plus M4 plus M6. And if we write sum term literals, then we can write as for M0 we can write A plus B plus C. For M2 that is 0, 1, 0. So we know that for 0 we have to write uncomplemented, for 1 we have to write complemented. So A plus B bar plus C dot. For M3, A plus B bar plus C bar dot. For M4, A bar plus B plus C, and at last for M6 we have 1, 1, 0 condition. So A bar plus B bar dot plus C. So this way we can write POS form based on the given truth table. Now Minterm and Maxterm both are logically equivalent. Maxterm is equal to Minterms. If we take a same truth table which we had taken for Maxterm as well as for the Minterm, we have 3 input variables and we have 8 different input conditions, and for certain combination we are getting output to 1, and for certain input conditions we are getting output 0. Now we have 0. If we identify output, we are getting output 0, then we have total 5 condition, that is 0, 2, 3, 4 and 6. And same way, if we consider output 1, then we have 3 condition, 1, 5 and 7. For 1, 5 and 7 we are getting output as a 1. So now if we write our function, then we can write f of ABC, that is equal to pi. Pi is POS form. So we are getting 0 for 0, 2, 3, 4 and 6. And that is equal to sigma m. Sigma that indicates SOP form. So we have Minterms and that 1, 5 and 7. So either it is a Maxterm or it is a Minterms. If we are getting output 0, then it is a Maxterm. If we are getting output 1, then it is a Minterm. So both are logically equivalent. And if we write again function f of ABC, then we can write in terms of Maxterm, then we have M0, capital M for Maxterm, M0 plus M2 plus M3 plus M4 plus M6. Because for 0, 2, 3, 4 and 6, we are getting output 0. And similar way, it can be written as a small m. Small m indicates Minterms. So M1 plus M5 plus M7. So logically Maxterm and Minterms both are equivalent. And function, either it can be represented in terms of Maxterm or it can be in Minterms. If any one term, either Minterm or Maxterm, if we know, then another Minterm or Maxterm can be identified easily. So this is all about Maxterm and Minterms. Thank you very much for watching my video. Keep watching. Thank you very much.